Drilling fluids touch just about everything in the drilling process. We're here to deconstruct the drilling process and drilling fluid concepts to provide a deeper understanding of our industry. In each episode, we'll share information, talk to interesting people, and maybe share a few stories along the way. Welcome to the Flowline, a production of AES Drilling Fluids, brought to you by Matt Offenbacher and Justin Gauthier.
Hey everybody, welcome back to another episode of the Flowline. Matt Offenbacher, your host, and I are here ready for another amazing episode. Matt, predictions? Well, this is not about the episode, but I just randomly thought about this. What's your biggest prediction for 2026?
I don't know.
I know it's okay. I'll be maybe more specific. I want to do oil price, all that. That's but biggest sector win. Like what sector just in general do you think is going to thrive this year? Like could be medical, could be tech, could be energy.
I'm commodities, right?
Right.
Well, I think there's two things. Like, okay, so you hear about everybody's pretty bullish on the end of the year. They're saying first half maybe not so much fun.
Yeah.
Second half. I think there are real headwinds on the capital spend with AI, and I think that could really affect tech or create a rationalization. Okay. So I think there's that. Of course, there's all the stuff, the black swans and the stuff you can't predict. But
yeah,
gold and silver are ripping already. It's one of those, and it goes back to with apps that will basically let you gamble under the guise of trading at this point. It's difficult to say how long speculative things can distort the market relative to market fundamentals. I think we wrestle with this on the oil side all the time. How much of this is paper and how much of this is physical? And
yeah.
So that is why I absolutely reserve the right to be completely wrong.
Yeah. I would. Yeah. I was going to say, I think towards the latter part of the year, I could see the sort of the housing market. I don't want to say it's like the biggest winner, but I could see that start to finally change. Being that my wife and I are in real estate, that's something we kind of closely watch. But I want to actually touch on your point, or stay on it, is like prediction markets. Mm-hmm. Like those things are like Polymarket and Cashy, or there's another one that those things are, I want to say, have a pretty big influence on outcome. But I don't know if it's because of the predictions and the money involved changes the outcome, or if it's just that there's like, you know what I mean? What's your take on it? Is it influencing the outcome, or is the outcome, but people just have such a better sense of knowing what's happening in that specific prediction?
The argument has always been like the market sort of finds those answers.
Yeah.
And it's kind of interesting. So I remember this was kind of like post 9/11 when everybody had some wacky idea. And there was a discussion on a futures market for attacks, basically, with the idea that it might help become a reliable predictor of events.
Uh-huh.
It seems like a twisted dark side to it too, right? But like, and it was, kind of pushed to the side, but like, there is a story, I don't know if it's true because it was just on X, but like clearly somebody knew something about what happened in Venezuela and put some money on action as far as would Maduro still be in power in a month or something, and made a bunch of money. Wow. And it was timed within hours of actual events, which, if it's all true and it wasn't just something somebody made up on Twitter for me to repeat, it would imply that, people with inside knowledge could profit from these things. Like, it's a whole other twisted thing. Yeah. So those markets are very interesting, troubling. Like, where's the ethics is sort of the part I can't figure out. And how do you keep people from betting their life savings on these things and ruining their lives?
That's the downside, right? For sure. And I've never done it, but I think it's fascinating. I'll go on Polymarket and see what's trending. And it's
absolutely.
Like, this amount of people think this is gonna be the outcome, and it could be anything. It could be whether it's sports or politics or freaking you name it, like
Yes.
the color of the sky tomorrow. Like it's like
Yeah.
everything and anything. People are somehow betting on it. It's so, but that just seems to be taking off more than anything. But nonetheless, that was just an interesting question. But we're not here to talk about prediction markets and gambling, as much as probably a lot of people do enjoy that. But elastomers, Matt, it's not something necessarily directly tied to drilling fluids, but just like our intro says, drilling fluids touches just about everything on a drilling rig. And therefore, elastomers is something it touches almost all the time, especially if you're circulating or if you've got mud in the hole and you've got tools in the hole. And so thought it'd be a good topic to kind of run through that from a drilling fluid standpoint. I will be the first one to admit I am definitely not a directional guru, nor am I a downhole tools, material science, and performance expert. So I will just ask questions.
Right, but we've been yelled at by some.
Yeah,
That's the thing.
or accused of silly things by those.
Yeah.
But anyway, elastomers or something. And you guys in the lab play with this stuff, and so
Yeah.
you're familiar, and you've kind of cut them open and played with them and beat them up and threw different fluids and oils at them. But so I think you have a little bit of credibility to stand on.
We try. I would just say one thing is there are a couple of quality elastomer compound manufacturers we have worked with.
Yeah.
If we don't play in the same sandbox as a company, we love to work with those folks.
Yeah.
Because you can see the gaps. And I mean that on both sides. But I think that if we cross this bridge, we can really make differences for our people or for our customers. And so we're happy to keep talking to the extent that we can share knowledge and information to make things better.
Yeah.
But a lot of the reason we have dialogue is a tool failed. It must be because of something in your mud. That is the amount of proof I have. And, it can be anything. So a lot of it is stators and mud motors. So, the progressive cavity motor where it's a usually chrome-plated rotor, rubber stator. You pump fluid through it. It forces the rotor to turn, provides power. But on RSS applications, it's not uncommon with O-rings and that sort of thing where there are seals that there's a chance that those might fail, and what happened, and why did it happen, and even if we didn't put it there in the mud, could have something in the mud have created a problem? So we help where we can to evaluate those things.
Nice, yeah. So let's talk about the materials because they differ.
Yeah, I mean, and look, at the end of the day, these are all some kind of rubbery type compound, right? So, and I will add a number of everybody's got a proprietary blend of whatever, right? So NBR or nitrile rubber, or the most common hydrogenated nitrile rubber. In essence, you can find those. You can get them on the internet. It doesn't mean it necessarily is the kind that is used in a mud motor per se. It's just that family. Mm-hmm. And then for more extreme applications, they're like FKM, or it's a fluoroelastomer, better known as Viton. There are a few other more exotic materials, but they get really expensive.
Okay.
And I know that because when I try and get samples of them, and they're like, you can get 5 inches for $1,000, we say someone else can test this. But in essence, think of a rubbery compound and think of it how it might interact with, especially like an oil-based mud, a solvent, right, or a lubricant or something like that. And you could see how there is a potential for these two things to interact. And so there's the one party who doesn't know anything about mud but has to at least know enough to come up with materials that are compatible. Yeah. And the flip side, the people who don't know anything about elastomers trying to come up with mud components pretty blind and not knowing if there could be a potential issue other than track record, right? Like, hey, we drilled with a bunch of wells and haven't had problems, so we should be good, right?
Yeah.
So
no kidding. So when it comes to reactions, so when the fluid passes over this material for a length of time, what are two of the things that can happen to that rubber?
So we'll talk more about failure modes, but I would say that one thing is the stuff. So you actually have material that causes the elastomer to swell. So something in the mud is actually able to absorb into the rubber material, swell, and when it gets bigger, obviously it can tear. A lot of these things depend on very reasonable tolerances, and you lose that tolerance. And so that's one way it can break down. The other way they can tear and break down is actually just to harden. So let's say one is I cause it to swell. Another one, it might be that I pull something out of the elastomer, and now it actually hardens and has less give and can tear that way. So, and keep in mind, this is all happening under pretty extreme temperature, pressure, friction.
Yeah.
And they can all work together, right? So I was talking to somebody about erosion of elastomer materials, right? Because it's rubber and you're pumping mud really, really fast through it. Mm-hmm. Well, some of that can be, certain types of solids can be worse, where they might actually just embed in the elastomer then start kind of tearing apart, versus like certain shapes and things have a tendency to do that, but normally only after the rubber starts to soften a little bit.
Yeah.
Things like that. Mention the chemical interactions. But, the thing is, if I cause this thing to swell and it's rotating in narrow tolerances, it's going to tear apart. If I erode some of it, it's going to have a leak. I'm going to lose power. And I got to come out of the hole because I can't, operate my tool. So all of these things can sort of come together. And then when you have this, what happened, and you have here's a chunk of something I got at the Shakers, it's like, well, it could have swelled and then torn, it failed. It could have torn from purely mechanical effects. Yep. So there's a lot of forensics in advance and even after the job to try and find out, okay, what happened.
Yeah. Well, let's talk into and double click on that. From the testing standpoint, what are some of the tests, and let's break down what we can do to evaluate either before, for design work, or if you're having to do sort of after action stuff.
A lot of it is just exposing the fluid to an elastomer. So you'll take a coupon. We call them coupons, but a lot of this stuff is, you can get it in sheets. You have a stamp, and you'll get, a lot of the coupons look like a wishbone kind of thing, or dog bone. And what you can do is, first you can test durometry. So they're going to have a set hardness. There's a rating for that. Okay. But we actually have a tool in the lab where we can see how hard it is, then soak it in drilling fluid for a number of days, and then take it out, and we can measure if it got softer or harder after exposure over a period of time at a certain temperature. Okay. The other thing is, how much volume did it swell? So sometimes if you vary pH, any of those kind of swelling, you have more friction, more heat build up. You might have some distortion in the shape. You lose power, or you just break it down. But the most common, not just testing up against elastomers, is doing something called testing the aniline point. We do this all the time for customers because they get diesel from the cheapest place they can find, out of the back of a rail car or something. So I was on PV Fluid Products, shout out to them, but they had a recommendation of keeping your aniline point between 160 and 195. Okay. We've definitely worked lower than that. But the issue is, aniline is something, it's a highly aromatic compound, and so it's more likely to cause swelling. So lower the aniline point, the more likely you're going to have that swelling, which ultimately could create issues. So a lot of times we'll get a sample of the base oil, and aniline point is a temperature. So you add aniline, you add your base oil, you heat it up, and you kind of give it a tap. And when the two things mix, that's the point at which your aniline point is. But we do a gazillion of those, and we plan to acquire an automated tester because we're doing way too many of them.
Oh, wow.
Aniline's kind of nasty. We'd rather not handle it also. So
I'm sure.
Anyways, it is sort of the short stick in the lab, like, hey, who hasn't done an aniline point in a while? Sorry. So,
nice.
The other thing you can measure is what's called modulus, or the force required to cause the elastomer to stretch.
Okay.
Elongation is kind of another aspect of that, where it's, how elastic or brittle it is. And there's ASTM methods for these. We don't have the equipment for this. Our sister company does, if it came down to it.
Okay.
And the other one that we do, like we don't do is tensile strength. Like, how much does it take to break that dog bone shape? Like, how hard do I have to pull, and how much does it change after exposure to fluid?
Yeah.
So there are certain tolerances and parameters for that. But I mean, you got a lot of variables too. So even the motor manufacturers have what that you would call temperature derating, where if you're running a motor at a higher temperature, expect less power is sort of what they say, because of how their elastomers are going to respond to higher bottom hole temperatures. So we can do a bunch of that stuff, but as you may notice, we're just talking about the elastomers.
Right.
And if I broke a tool, it could be, we don't have any mechanical something rotating against something, right? That gets obviously way more expensive and complex. I know there's a couple of places that they call them dynos, where they have like really short sections that they can test, like the rotation of a rotor and a stator. We've talked about corrosion, especially chrome on rotors, but if it corrodes or whatever's actually going on down there, then you've no longer got this nice, beautiful, smooth chrome surface. You have something really sharp that's going to start cutting up the elastomer, and may accelerate some interactions. The other thing I'll add, like especially on the RSS side, where we've seen with O-rings, is beyond just like them failing to seal. We've encountered where we were on a trial using clean mud, so like mud that hadn't ever been through a bit before, like very little seed mud. And so it was actually very thin, and it was bypassing the O-rings, where it actually needed more body for the way those O-rings were calibrated.
Yeah,
it just didn't have enough solids in it yet. Even little I've seen that we had this happen with a choke once, where it was like really clean mud, and they were like, we got a leak. And it was like, oh, you need solids packed off in there again. That's what happened. So weird stuff like that can happen.
Yeah. So what would you consider the most common failures are, or failure modes when it comes to mud?
I would say that the most likely and most common culprit is the base oil, especially when you get into all of these weird fractions we're dealing with on kind of crappy diesel and those sort of things, where it's like, hey, I'm not going to put this in an engine, but I can make mud out of it. It's just, it goes back to we can't test every load against an elastomer. We can't, it makes mud fine, but it's a little harder to screen for. And this is probably somewhere where, we could get a more robust data set someday if we were able to do more detailed analysis, like what works, what doesn't. A lot of times we're only looking at what's wrong.
Right.
I think that's a big one.
Yeah. And I wonder, and it's been a long time since I've been involved with any sort of base oil testing, but from say load to load, different diesel providers, from your understanding, is there a pretty wide degree of change with diesel properties, like from load to load, if you're getting it from say similar people? Do you know? Or
there can be, right? Because there's these teapot refineries, there's how much kerosene is in it, there's seasonal varieties, and so because diesel's not a molecule, it's a combustion spec, it can just have it's aromatic rich, and it can have a lot of stuff in it. Right. And people aren't always checking. So I would say that it can vary. Our GC by GC looks like it can pick up a lot of, it's been amazing for us to be able to run GCMS on like 4 different muds, and, one of our chemists to be like, I can tell you these two came from the same place. And you're like, whoa.
Yeah.
So the tools are there, but I don't think there's a ton of it's just too hard to keep track of, Yeah. So.
Well, then that kind of leads into my next question. When it comes to synthetics, from a consistency standpoint, I would imagine that you can kind of I guess, not worry as much about where it's coming from, assuming that it's coming from the same refinery and the same vendor. But do you think a synthetic could be more compatible than a diesel in oil-based mud when it comes to this elastomer conversation?
It should be. I think just because, like, the same benefits we get from, like, the fewer aromatics, right, the safety and that aspect. The other thing is a lot of those, because they are a molecule, they have a specification. You can design around that, and you're going to get the same thing every time. And so, from the alternate synthetics and mineral oils, you're getting a much more consistent product. I have heard, and I don't know, there's a lot of arguments about, okay, the kinematic viscosity of the oil is helpful in, like, deep water applications and that sort of thing. Mm-hmm. But the fact of the matter is, your base oil is always in mud, so, like, the ultimate viscosity is dictated by the full composition.
Yeah.
However, perhaps as a very minute, extreme situations, I've heard that there can be more friction from low kinematic viscosity base oils that may affect reliability at a certain point. The challenge here is you're always calculating for a little bit of swell, right? Like, your tolerances when you're designing, when you're doing these elastomers, you expect them to change when they go down hole.
Yeah.
Right? And if you can't get that right, the thing's going to tear itself apart. But you would think that'd be far more predictable in a consistent molecule like a synthetic oil and that kind of thing, provide you that reliability. But it may just be that, people are better schooled in using certain oils and they're more comfortable with that. I would argue that if there's enough knowledge there, synthetic should always be more consistent, more reliable.
Right.
And look, that's what people are drilling the most extreme wells all around the world. They might not be using mud motors like we do, but they figured it out and they have a protocol to make this work.
Right.
So I hope we can pick their brains.
Yeah, no, that's true. So what do you think we're not accounting for?
I mean, I think the big miss is just the mechanical aspect of the environment, right?
Mm-hmm.
There's a lot of, like, oh, well, it could be your emulsifier or whatever. It's like, well, these chemistry families are pretty similar. I don't think there's enough nuance there to, make a difference. But, I alluded to, like, the rotor corrosion or just, like, other mechanical interactions that are happening that, okay, well, the rubber came out torn up and it looks in bad shape, but do we know the mud's the origin of that? The other thing, I mean, we like to beat stuff up. It's the oil field. So, like, how aggressive are you going from, like, sliding to rotating? How, like, what are some other things? Stalling and, like, what's going on the EDR that says that you're following the manufacturer's recommended specifications? And I've seen this where it's like, hey, we don't think it's the mud because we have you on a couple of rigs, but it seems to be this one rig is yours, and we're having these problems. And it's like, okay, well, can we talk to the driller?
Right.
There's no, like, magic chemical interaction, I think, that's necessarily happening outside of the ordinary, but we got to look at all our behaviors too. And once again, we can see some of that in the EDR, but can we measure it all? So, even the composition of solids that might cause a tool failure, when we argue about low gravs, it's kind of interesting. Like, in the Eagleford, they're not only obscenely aggressive with tools, but they're pretty comfortable with really high low gravs. And, it could be that those solids just aren't as brutal as, I mean, they're definitely not as bad as trying to do this through a sand or something, but, they've figured out their limits and what works.
Yeah.
So,
no, that's a good point. And I guess it comes down to just cost, right? Like, you would think that there's a material out there that could withstand anything. But then that comes at a cost. And so it's constantly fine tuning, finding different, rubbers and materials. And, because mud really hasn't changed much. So it's not like they're having to keep up with us. It's more probably them just fine tuning their supply chain and trying to figure out the most efficient, cost effective way of running a rubber.
Well, and like I said, I still think there's a substantial knowledge gap. I've actually done lunch and learns at elastomer providers just to try and educate them.
Yeah.
And it is, the most basic, and by no means mean this as a criticism. I'm glad we're talking, but like, you'll talk about some basic stuff. It's like, write that down, and so it's like, okay, we're further apart than I thought, and so it may be that we're just chasing the wrong rabbit holes when we're looking for these things. So and I mean, even in a company, I used to work for a company that had a mud company, that had a directional company, and they were so siloed. I mean, I think that's true of any a company large enough to have all these other companies underneath it, or departments or whatever. What you're going to find is it's going to be there's still going to be huge gaps, or I don't have time for this, or what have you. So I just think there's still opportunity out there, but it's the gaps are big, where it's like, okay, well, we're going to design this material, and all I can do is test it against something and see if it looks good at surface that doesn't account for all these other factors, and then hope it works. And the flip side is, the one that works the most often, I'm just going to stick with, because I'm too afraid of the unknown to try something else. So
no, that's a good point. Well, that's all the questions I have, Matt. But I would encourage, if there's folks out there in the elastomer world, or if you're doing design work, it's good to team up with somebody and collaborate before you're end up running into issues or having to solve problems ongoing, or on the fly. But good conversation nonetheless, Matt. Any closing last words before we take off?
I would just say that, like, this is something that affects our customers, and so we're very open to working on it. I'm not promising anybody anything, but we're looking at this stuff internally just as much as we might entertain a conversation or two if we could do more. So
that's a great point. Well, with that said, folks, if you'd like to reach out to Matt or I, you can connect with us on LinkedIn, or you can send us a good old-fashioned email at theflowlinepodcast@aesfluids.com. Be sure to check the website, the YouTube channel. Again, we just are continuing to put out a ton of great content to educate our listeners and audience. And with that said, take care, everyone. Till next time.
Take care.
Thanks for listening. Please tune in next week for another exciting episode of The Flowline. And remember, may your returns always be full and your trips always smooth. Views expressed in this program belong to participants and not their employees. The program is for informational purposes only and cannot take the place of seeking professional advice. Copyright AES Drilling Fluids.